Hello, math scholars. Glad you're joining me today for a video. I'm at a meeting. So what we're going to be doing is working with Desmos side by side with this video. So make sure you have two tabs open. One tab open for the video you're watching in YouTube, and then one tab open with Desmos. You can do a Control-T to open another tab, and then you can just kind of toggle back and forth while you watch the video. Go ahead and click pause and try this warm-up and see if you can find where the student made a mistake. All right, you're back. So where the student went wrong is they used the wrong formula. X equals negative b over 2a, and they did just positive b over 2a. So to kind of correct that, we would just turn that 16 to a negative, and that would make that answer a negative 4. So the axis of symmetry would be at x equals negative 4. So today's lesson is 9-6, solve equations by graphing and factoring. Feel free to take notes along with me in your notebook, so that way if we have a note check, you'll be ready. If at any time during the video I get going too fast, just click pause. All right, so what's super cool about quadratic equations is you could solve them by graphing. Basically, the solutions are also called roots, or also called zeros, but they are located at the x-intercept locations. So as long as you have a graphing tool at your disposal, like Desmos or a graphing calculator, all you have to do is look for these x-intercepts. Isn't that awesome? So let's figure out where these are. 1, 2, 3, 4. So x equals 4 is one of my solutions. And 1, 2, 3, 4, 5, 6. 6 is my other solution. Awesome. Sure beats the quadratic formula, huh? A lot less work. All right. And what's really cool is on the air test, you have Desmos. So it'll be a pull down, and you'll be able to graph and look for solutions at any time that you want. All right. Let's together estimate the solutions from these graphs. Let's look at part A. Where is this parabola touching the x-axis? Where are these x-intercepts? It's never touching, is it? That just means there's no solution. I'm writing with my mouse, so just be patient with me today. Because I'm doing computer work, not at the smartboard. All right, part B. Where's the x-intercepts located? Right here. So I would state that the solution is at x equals 1. And then down here, looks like we have two x-intercepts, and they're kind of at decimal locations. So just estimate those the best you can. On Desmos, they will give you the exact value. But I'm going to go with negative 1.6. I'm just estimating. And maybe negative 4.5. Okay? I'm just going to estimate. So we're going to solve our first one by graphing. You definitely want to make sure it's set equal to 0 before graphing. If you did not have Desmos and they were forcing you to do it by hand, you would just pick a few x and y values. It just kind of seems difficult because you would maybe pick some negative numbers, maybe pick some positive numbers, maybe pick 0, but you would just be crossing your fingers that you would find the intercepts through that method. So that's why I'm choosing to show you Desmos today. So we're going to open our Desmos and put in the equation x squared minus 6x plus 5. Y equals x squared minus 6x plus 5. Just going to make sure I typed it in right. X squared minus 6x plus 5. Perfect. Just going back and forth from our Desmos to our slides. There's my Desmos. All right. So what's awesome and what I love about Desmos is they will show you those coordinates if you hover. So they'll show you all the important parts about the parabola. They'll show you the vertex is at 3, negative 4. They'll show you the y-intercept is at 0, 5. And then our solutions are at 1 and 5. All right, so x equals 1 and x equals 5 are our solutions to this quadratic. Okay. And I can do a quick sketch if I want to, but I'm not going to worry about it because we saw it on the Desmos. Okay, there it is. Pretty cool. I'll clear this out for my next example. Hey, now's a great time for our keyword of the lesson. Remember to keep this a secret from all your friends. The key word is Olympics. Olympics. You might have to figure out how to spell that. But I loved watching the Olympics this year. The Olympics are a highlight of my whole year. I look forward to them because I really enjoy the winter and summer sports. All right, next. This just kind of shows you sometimes you'll get two solutions depending on where your parabola is located. Sometimes you'll only get one solution, but sometimes if your parabola is up real high, you'll have no solutions. We kind of saw that a couple slides ago. So just be aware those are all the possibilities. All right, let's try this one. We need to get it equal to 0 before we type it in to graph it. So to get this one equal to 0, we'll do a subtract 3 on both sides. We'll have x squared minus 2x minus 3. These two are not like terms. I apologize for putting them underneath each other. They are not like terms. They cannot combine. This is what we're going to want to type into Desmos. X squared minus 2x minus 3. X squared minus 2x minus 3. And notice I did not even need to type in y equals. I think you can type it in, but I don't think it's a necessity. Okay, so just be aware of that. You don't need to type it in. And here's my key features of the graph. My vertex, my y-intercept, and my x-intercepts are my solutions. So -1 and 3. X equals -1 and x equals 3. Okay, and there's your picture if you need to see it again. All right, let's get this equal to 0, graph it, and look for those intercepts. So to start off, we'll subtract 1 over to the other side. X squared plus 2x minus 1 equals 0. Let's head to our graph. X squared plus 2x minus 1. X squared plus 2x minus 1. So we'll hover with our mouse, and hovering with the mouse will show you those intercepts. Ooh, these are kind of tricky. I might want to jot these down so I can remember them. -2.41. I always like to round to the nearest hundredth. And 0.41. So we'll go ahead and write down those answers in our notes. X equals 2.41 and x equals 0.41. Oh my gosh, this is embarrassing. I think I typed the equation in wrong. There should have been a negative out front. I am so sorry. I'm not going to redo the whole video, so just bear with me. We're going to go back and plop that negative out front. That's going to make this actually have only one solution at 1. There we go. So it just shows Mrs. Hart makes mistakes too. So let's go ahead and erase this. +1 is our one and only solution to this problem. And there you have it. If I was better at editing videos, I would edit that out, mistake out, but hey, you can bear with me. All right, next slide. We're going to start by subtracting our 4x over. That is not going to be able to combine with any of our other terms. So we'll have x squared minus 4x plus 7 equals 0. Since now we are equal to 0, we are ready to type this in and see what the graph looks like. It was x squared minus 4x plus 7. Oh, look at that. That is up too high to have any x-intercepts, so that means I would write no solutions. No real solutions, that is. Might be imaginary solutions. Right, and we're going to end the day with 2 problems where you solve them by factoring, and we have actually already done this year, so that's why we're not going to spend too much time on it. This is a classic old-fashioned factoring technique where we are thinking of numbers that multiply to 8 that would add up to 6. So, what are the numbers? +4 and +4 and +2. And that makes the solutions a -4 and a -2, because those are the numbers that when placed in for x would cause these to be 0. okay? Because zeros and intercepts are the same thing. You can check yourself in a variety of methods. You could put these numbers in for x and plug and chug and make sure you get 0. Or you could just graph it and see that the intercepts are -4 and -2. Let's go ahead and check ourselves in that manner. X squared plus 6x plus 8. Look at that. Our intercepts are -4 and -2. This is a great way to check. And one last factoring problem. So we are trying to factor this. It is technically set equal to 0 because there's nothing on this right-hand side. Is there a common monomial I could pull out front? Unfortunately not. That means we're headed to the box method. Let's draw ourselves a box. Go ahead and do this right along with me. Hey, let's throw in another key fun word. My husband's name is Nick. His name is Nick. I'm going to ask some questions in the mini quiz about this stuff, keywords. Make sure you watch it. So put our 12x squared right here. Put our 2 right here. Let's multiply them together and get 24. So I'm thinking of numbers that would multiply to get 24 and add up to 11. Can you think of those numbers with me? 8 and 3, I believe. Now, all you biology people, you're going to pull out your common factor in the top boxes, 4x, and then you're going to work your Punnett square backwards. 4x times what is 12x squared? 3x. 4x times what is 8x? 2. 3x times what is 3x? 1. And then 2 times 1 is 2, so it all works out. I'm going to write it in factored form. I'm not the best at writing with my mouse, I apologize. 4x plus 1 and 3x plus 2. This is all set equal to 0, so we finish with our zero product property. So here's how the zero product property works. You set both these binomials equal to 0, and you solve for x. So either this equals x, or, 4x plus 1 equals 0, or 3x plus 2 equals 0. To solve this equation I have here, I would subtract 1 to the other side and finish it off by dividing by 4. So my final answer would be -1/4. Over on this side, I would move my 2 over by subtracting it over. And then I would divide both sides by 3, so -2/3. Now when we go to check this, and we go to graph it, just to see, be aware, these answers will be decimals. -1/4 is -0.25, -2/3 is -0.6. See the whole problem there? So what we're going to go to graph in Desmos is 12x squared plus 11x plus 2. And we're checking that our intercepts are the 2 solutions we got when we did our factoring. So 12x squared plus 11x plus 2. And I can zoom in a little bit. Do my plus button. There you have it. -0.25 and -0.6. And if we check, I believe that is what we had. Sweet. So thanks for joining me for the lesson. Let's see how long it took us. Only 13 minutes, not too bad. You're going to have a little quiz in Polaris just to ask you a few questions. Make sure you watch the lesson today, and then you have a worksheet for the homework. So thanks for joining me. Bye.